What causes welding burn-through on thin-gauge materials? Imagine you're trying to weld a piece of metal that is only a few sheets of paper thick. It might seem easy, but if you're not careful, you could punch a hole right through it. That's what burn-through is all about. When welding thin materials, like sheet metal used in car bodies or electronic enclosures, controlling heat is key. If too much heat gets into the metal, it melts completely, creating holes or weak spots. The main reason for burn-through is excessive heat input during welding. When the welding current, or amperage, is set too high for the material's thickness, it produces more heat than the metal can handle. Thin metals have less mass to absorb and spread out that heat, so they heat up quickly. If you hold the welding arc in one spot for too long, the heat concentrates there and melts through. Moving the welding torch or electrode too slowly can also cause burn-through. Slow travel speeds allow heat to build up in one area, increasing the risk of melting through. Moving too fast might cause poor fusion, but it's less likely to cause holes. Finding the right speed depends on the metal thickness and the welding method used. Choosing the wrong electrode or filler metal can make things worse. If the filler metal has a lower melting point or is too large, it can add extra heat to the process. Using a filler material suited for thin-gauge metals helps keep heat levels in check and prevents burn-through. Joint preparation is another factor. Thin metals need to be fitted tightly with minimal gaps. Gaps cause uneven heat distribution and weak spots that burn through more easily. For very thin sheets, welding without filler metal, called autogenous welding, is often better because it reduces heat input. The welding technique itself makes a difference. Using stringer beads instead of weaving motions helps limit the heat-affected zone. When welding with a metal inert gas or gas-metal arc welding process, pushing the gun, directing the wire toward the cooler edge of the puddle, instead of pulling it, reduces heat concentration and burn-through risk. Machine settings are also important. Besides amperage, voltage, polarity, and pulse settings must be correctly adjusted. If these are left at previous job settings, they might cause excessive heat. Always double-check your machine before starting. In manufacturing and mechanical engineering, controlling heat input is essential for welding thin-gauge materials. Selecting the right process, like tungsten inert gas or pulsed welding, adjusting amperage and travel speed carefully, ensuring proper joint fit-up, and using suitable filler metals all help prevent burn-through. Mastering these factors results in strong, clean welds on delicate metals used in precision parts and assemblies.